All right, today we're going to cover two sections of chapter 3. One will be the addition of whole numbers. And the next one will be the opposite of that, will be the subtraction of whole numbers. Yes, we know what that means, but think back when you were in school, when you were first being taught addition and subtraction, as you were just being taught numbers, period. So that's going to be the difficulty of when you're going to be in front of the classroom helping these kids. Two things we have to discuss first. These symbols. N stands for the natural numbers. Natural numbers are the counting numbers. Which are, if you're asked to count, you start with 1, 2, 3, and then keep on going from there to infinity. So that's, whenever you see the N like that, that means natural numbers. Next, we were introduced to the number 0. And that's going to be with a W. And we call those whole numbers. They're natural numbers plus the 0 number. 1, 2, and so on and so forth. Right. These symbols are called sets. Anything inside these squiggly lines are sets. We talked about those in the first couple of chapters. All right, so that's what we're going to look at in order to define these things, because we have to define which sets of numbers we're dealing with. So if we're dealing with a set of numbers of natural numbers or whole numbers, they're not the same. Let's define whole number, or addition of whole numbers. Okay, so we have two sets. Let A and B be two disjoint sets. They could be finite or they could be infinite. We're here when we get if they're finite. Because once we have finite, then that means they're like only 4 of them or 6 of them. If the cardinal number, the cardinality of A is equal to little a, and the cardinality of B is little b, then A plus B is equal to the cardinality of the union of those two sets. Remember this. The number of elements in X. That's what that symbol means. That's what little n means. Okay, now we're going to look at different ways that we introduce this to students. So let A and B be two sets. They're disjoint. They don't have to be the same. If we look at a Venn diagram, there are two non-overlapping sets. If we add the cardinalities of the two, then we get the union of both sets. And that's how we introduce things to students, to kids. When we say that 4 is represented by 4 little blocks, and 3 is represented by 3 little blocks. If we have 4 plus 3, then it's the union of this set and this set. So it's 1, 2, 3, 4 from this one. 1, 2, 3 from this one, which equals 7 blocks. Again, this is how we introduce mathematics to kids. Let's look at the number line. Or since we're dealing with number line, these are set locations. I'm sorry about this pen's acting up. Well, so it's the measurement model. We introduce this number line to kids. It begins at 0, and we start counting. 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. So we have to stress the point that numbers represent a distance. It's a measurement, how far something is from something else. So if we start at 0 and we add 1, we get the what? That's 1. Add another one, that's 2, and so on and so forth. So if we do 4 plus 3, addition we introduce as going to the right, because that's the way we count. We count this way. So we start at 0, go to 4, and then from 4, we add 3 more. 2, 3. So the final answer is 7. Again, it sounds easy for us, but remember, these kids' numbers mean nothing. All right, so first one, since we're dealing with numbers, we're going this way. This is then telling us the same way when we read, when we look at things, go from left to right. All right, then the next thing we do in our classes, once we introduce to the students the concept of number placement, what numbers are, what they represent in addition, then we look at the ordering of whole numbers. What that means, if I gave the student a whole bunch of digits, then I would ask them, okay, put them in order. And that's what we're saying. So we're saying what we're looking for here now is less than and greater than. This is where we introduce this concept. So we have, let's define less than. For any whole number, no whole numbers, A and B. A is less than B, right? And again, this is where you would introduce the inequality symbol. And usually people say the alligator. The alligator or the lion always goes for the bigger piece of meat. Or you can say it always points to the smaller one, the cute one. So for any whole numbers A and B, A is less than B if and only if, again, I'm going to start writing IFF for that. There exists a natural number K such that A plus K equals B. Yeah. Put that down here. A plus K equals B. All right. So again, that's how what does that mean? What's how we prove that? Let's say A is 2 and B is 5. We make our number line. Again, these are the counting of natural numbers. To introduce whole numbers, I'd say it begins with a whole and then it digs itself out. So that's whole numbers. So now we're going to say that A is less than B if here's A and here's B. A is less than B if there's some number K I can add to A to go to the right. If I have to add a number to A to get to B, then A is less than B. All right. So now we'll look at greater than. That definition. For any whole numbers A and B, B is greater than A. B, I do it this way. So we stay with the same as previous. B is greater than A. B is greater than A. And we write that B is greater than A if and only if there exists a K Well, we could just, you could look at the same way as previous, but there's just K. Such that A plus K equals B. Remember, we haven't introduced subtraction yet. And equal to is if we don't have to add anything to it. So here on the number line, I'm saying B is 5, A is 2. Is B greater than A? In other words, is 5 greater than 2? Let's see. To get to 5, what do I have to do? I have to add anything to A? 1, 2, 3. So yes, 5 equals 2 plus 3. So yeah, this method is what they call counting on. It's when counting on is when you add, when you count. A method in which you count on from one number called the A to get to another number. That's B. That's the count on method. We also look at something called doubles. They're adding the same numbers. So A plus A. All right, so then once they learn 1 plus 1, add another one, then you can move on to 2 plus 2, and then so on and so forth. Just keep on adding those numbers. So let's see, I'll show you. So if we had 4 plus 4, and we did the model, the count on model, then we know that that's going to be 8. So we start at 4, and we add 1, 2, 3, 4, 5, 6, 7, and that equals 8. So 4 plus 4 equals 8. Because now we can go on a little bit further, and we can say 4 plus 5. If they can do this, then we just add one more step. And from 8 to go to 9. So then 4 plus 5 equals 9. And then plus 2, plus 3, plus 4, plus 5, whatever you're going to do. All right. Beginning of each math class, I always start off by discussing the properties of mathematics. These are the rules on what we can use to study and learn and teach math. So this section is entitled Whole Number addition properties. Okay, so invariably, this is what you're actually teaching them, but without giving it all these names. The first theorem. One says the closure property. Of addition of whole numbers. The closure property is pretty important. In other words, you have to make sure that your numbers stay within the type of numbers that you're dealing with. Here's a definition of it, the formal definition. So, if A and B are whole numbers, then A plus B is a unique whole number. All right, what that says is it's unique because when you add two numbers together, it can't equal two separate numbers. 3 plus 4 equals 7, and only 7. It's unique. All right, so now let's see. What does closure mean? What this is saying, since we define that A and B are whole numbers are everything from 0 to infinity. So if you add two whole numbers, the sum or addition of the two numbers will also be a whole number. That's what it says. So if you start off with a set, will the answer also be in that set? Because if not, then we have issues because you're outside the range of what numbers we're using. Okay, so this how okay, besides the closure property, the next property that we have to discuss is actually the first property is the commutative property of addition. And since we're limiting ourselves to whole numbers, commutative property of whole numbers. To commute means to move. So when, let's say, commuter train goes from point A to point B, it moves. So the commutative property we'll define this as theorem 3.2. It says if A and B are any whole numbers, then A plus B, which we've just determined that because of closure that exists. If that's true, then so does B plus A. The order of which is not important. If we have 2 plus 3, or if we have 3 plus 2, they both equal 5. Again, you can use the number lines. For the first one, we start at 2, so we'll go 2 to the right. Now we add 3, so 1, 2, 3. It equals 5. Or we can start at 3 and add 2, 1, 2. It also equals 5. Again, we try to make things much easier for the for the kids to learn so that they can apply this stuff. So in other words, it doesn't matter how we write the numbers, as long as the same operations in between them, then it works. The next property. Associative property of addition of whole numbers. Associative property. The associative property, when you associate with someone or some group, you guys what you're forming. You're forming a group. The associative property is you're forming groups. All right, so it falls under this theorem. It's the associative property. It says if A, B, and C are any whole numbers, then also the beautiful thing about this is where we start introducing with some of the other symbols we use in mathematics. So if we have A plus B plus C, that equals A plus B plus C. But if I give you 3 numbers, let's say 3 plus 4 plus 5, the first thing you'll do is left to right. It's natural instinct. 3 plus 4 is 7, 7 plus 5 is 12. Same thing on this side. But so that's again, nothing can process more than 2 bits of information at any one time. So this is where we introduce the concept of parentheses. The parentheses forms a specific group that we have to work on first. All right, so that's the grouping method there. The parentheses this first. That's what it's telling us. Because also we have to get to the point of teaching the order of operations to the students, which comes in after we discuss all these. All right, so in this one, so 3 plus 4 is 7. Four plus 5 is 9. Do I need the parentheses? There's nothing in front of it around it, so I could just drop the parentheses. Same thing here. Now, 7 plus 5 is 12. 3 plus 9 is 12. So that's how we introduce the associative property to the students. All right. Yeah, and we do the same thing with the blocks there. We do the same thing with the blocks. So, for example, with blocks, I have 3 blocks. I have 4 blocks. And I have 5 blocks. What you would do first is your parentheses would be around here. Tell the students it's where I'm plussing. So if I put all those together, then I have 7. Then if I combine all these blocks together, then just count those and you come up with 12. Right, so this is how you introduce these concepts to them. The next property the identity property. Of addition of whole numbers. We have to discuss what identity means. Identity is keeping yourself you. So it won't change you. Does not change the value. Okay, here's a theorem. Because we're going to look at these properties also with the other operations, the subtraction, multiplication, division. See if which ones work, which ones don't. So the identity property of addition says there is a unique whole number 1. All right, not 1. That's from multiplication. 0. Called the additive identity identity such that for any whole number a plus 0 is a. It keeps itself. And because of commutativity, we can go 0 plus a is also a. So let's look this up. 3 plus 0 equals 3, or 0 plus 3 also equals 3. I first go to number 3. So I start at 0. 1, 2, 3. And I don't go anywhere. So I stay here. It equals 3. Or this one, I start at 0 and stay there. Then I add 3. 1, 2, 3. Also equals 3. All right, let's look at some examples of these so far. It's the instructions here are which properties of whole numbers are illustrated below. The first one. 5 plus 7 equals 7 plus 5. All we did was move here, and to move is the commutative property of addition of whole numbers. So all we did was move them around. The next one. 1001 plus 733 is a unique whole number. Since we add two numbers that are whole, these are both whole numbers, and we add them together, it's also a whole number. So this is the closure property of addition of whole numbers. Three plus 5 plus 7 equals 5 plus 3 plus 7. Now, yes, the first thing you want to think about is it the associative property? Not really, because the 7's never inside parentheses. The associative property is when I group the first two, then I group the last two. Only thing I did here was switch these two. So this is the commutative property. Of addition of blah, 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 blah. Because again, associative is the first two and the last two. All we did here is switch these two around. Eight plus 5 plus 2 equals 2 plus 8 plus 5 equals 2 plus 8 plus 5. All I did here was 8 plus 5 plus 2. Just switch these around. So this is the commutative. Then in this one, I switched them around. The parentheses. I switched from 8 plus 5 to 8 plus 2. So this is the associative. Of addition of whole numbers. All right. So those are important because those will help the students understand and keep track of what's going on with their numbers. Sorry about that. Now, next we're going to talk about are the addition algorithms. Algorithms are simply rules, procedures, instructions. We'll look at different types, different ways of approaching these. Yeah, so first one we're talking about the base 10 blocks. This develops the standard algorithm. That also means to develop the standard algorithm. All right, so first thing we have to do is when we teach kids, we teach them the single digits. I said two is represented by two boxes. 4 is represented by 4 individual boxes, and so on and so forth. Then we jump into the 2-digit numbers. 10. Instead of putting 10 individual boxes, we use the bar. This represents 10 blocks. And so then we introduced them to the number 12. The number 12 is made up of this number here, which is a 10, and the number here, which is a 2, which can be represented as a long bar plus 2 individual ones. All right, so when we give them this, we give them something like this and ask them to tell me what number does this represent. So there's 3 of these, and there's 5 of those. So that's the number 35. There's only one long one and 7 small blocks. So that's the number 17. Because this is 10. What this represents is 10 plus 7 is 17. This is where we start introducing the concept of addition by adding the blocks. All right, so let's look at an example here. Let's say we have the number 14 plus 23. We'll first have them do it with blocks. So 14 is represented by one big long one. That's the front number. And 4 blocks plus 2 big long ones and 3 small blocks. If we put them together, we'll have 3 long blocks. And there's 4 from the first one and 3 from the second. So that's 30 plus 7 equals 37. We haven't got to the carryovers yet. Then the next method, this is method 1. That's the construction method, you could say. Then second method we could show them is 14 plus 23. I wouldn't go to this method until they got this, because then they know that if we look at here, these small numbers, it's 4 plus 3 equals 7. So 4 plus 3 equals 7. And these are the 10s. 10 plus 20 is 30 with a 0 behind it. Add those together, we get 37. This is the expanded method. The expanded method says 10 plus 4, 20 plus 3, 30 plus 7. That's basically what it says. Then we get to the standard one. If we had 14 plus 23, straight down, 4 plus 3 is 7, 1 plus 2. And we start going faster and faster and faster that way. All right. That's a good next. That's a good. Introduce the ones, tens, hundreds. So we know we tell them that that equals the number 1. And if we had 10 of those, then that equals 1 long bar. And that equals a 10. Seven, 8, 9, 10. When we have 10 large, 10 block rows, 10 long rows, then we have a block, a big block, which is 100. What that means is that there are 100 of these little blocks in there. And so on and so forth. Until they understand what the difference is between these three shapes. All right, so that's the important part. There's now from this point, we can start looking at carrying overs. We start off with, let's say, 9 plus 3. So this first one has 9 blocks. 5, 6, 7, 8, 9. This, then we add 3 more blocks to it. We put them together. So we put them in groups of 5 now. Or you can make them put them in groups of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have 2 more left over. So what you have here is a 10 block plus 2 is 12. So 9 plus 3 is 12. We'll teach that to them as 9 plus 3. 9 plus 3 is 12. Put the 2 down, put the 1 up here, and then carry it down. I'm not going to say it's easy, but it'll take time and they'll see what's going on there. So if we had 376, 459, eventually they can get away, hopefully, from those. This is once they get comfortable with the blocks and they understand the numbers. So they can even use their fingers. So we have 9. We need 1 more. So we have 6 up here. So we have 9 plus 1 is 10. Plus 5 more is 15. That's 5. Carry the 1. 1 plus 7 is 8. 9, 10, 11, 12, 13. Carry the 1. 1 plus 3 is 4. 4 plus 4 is 8. Again, 4 plus 4, once you get that, once they understand the doubles and everything, it'll make it much easier for them. Or it may be easier just to go and do the expansion. So there's 3, it has 2 spaces. 4 has 2 spaces. There's 7, has 1 space behind it. There's a 5 with 1 space behind it. And it's 6 and 9. The expanded version may help them even more. Because you have 9 plus 16, 9 plus 6 is 15. Zeros. 7, 8, 9, 10, then 12. Which is straight down, so that's 0, that's 0, and that's 7. So this number goes over there. So we have 700 plus 121. No, 130. I'm sorry. Because this is a 10. It goes under the 10s. And this one So if we line them up. Add straight down, we get 835. And I'm not gonna say that that's the only way of doing it. It's just we can just keep on doing that. Whatever's easiest for your kids, because every kid learns at different paces, so each class may be different. All right. So another one is called the partial sums. Which is similar to what we just did. So we have, let's say, 568 plus 757. So now we have, let's look at the first two numbers. That's 500 plus 700 equals 7 plus 5 is 12 with 2 zeros behind it. Then we have the 260 plus 50s. There's a 0 at the end. 6 plus 5 is 11. And then 8 plus 7 is 15. So add straight down 0, 0, 5, 1, 2, 2, 1. So that's partial. Or you could do it starting from the right to left. You could do 8 plus 7. 8 plus 7 is 15. Then that one and that one. So you could build it up. You had 568 plus 757. Start with the ones. 8 plus 7 is 15. 60 plus 50 is 110. And then 500 plus 700 equals 1200. Add straight down. So that's partial sums. The next one is interesting, but it may be complicated for the kids. It's called the lattice algorithm. Those are the same as numbers we had last time. We look at 568 plus 757. What we do in the lattice algorithm, so we have 568, 757. So in this first one, 8 plus 7 is 15. That's the tens, that's the ones. 6 plus 5 is 11. 5 plus 7 is 12. Now we add up all the diagonals. So 5 by itself, 1 plus 1 is 2, 1 plus 2 is 3, and then the 1. If the students understand this, even better, because I think it's a lot faster. So let's look at the other example. 3, 5, 6, 7 plus 5, 6, 7, 8. So 3, 5, 6, 7, 5, 6, 7, 8. Seven plus 8 is 15. 6 plus 7 is 13. 5 plus 6 is 11. 5 plus 8. 5, 3 plus 5 is 8. Extend these diagonals. So 5. 1 plus 3 is 4. 1 plus 1 is 2. 8 plus 1 is 9. So the answer is 9, 2, 4, 5. That's one of my favorite ones because if the students can understand it, then it's great. That's called the lattice. The column addition algorithm. Okay, in this method, we add the numbers in each column and writing each the answer, the sum, underneath each of the columns. So we do each one at a time. So let's look at 144 plus 37. So we have in the ones, the 100s, we have a block. In the middle column, we have those 4, those 3, these 4, and these 7. So first, we add the ones column and the tens column. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these equal along. So we have 11 blocks. So we have 10 of them and 1 left over. So this 10 goes here. And it's gone there. So we only have that one. And then we still have this one here. And we add these. So we have 1 over here. Can't go any further. 1, 2, 3, 4, 5, 6, 7, 8. Can't go any further. And there's 1 there. So it equals 181. You can break it up into pieces like that. All right, let's make another one like that. I figured it. Again, the blocks will be a safety mechanism for the kids. Let's take another example. 568 plus 357 using the column addition. So we have five, 6, 8. That's our first number. 3, 5, 7. Oh, 8 plus 7 is 15. 6 plus 5 is 11. 5 plus 3 is 8. But you can only have one number in each box. So this one comes over here. So we just have a 5 there now. 11 plus 1 is 12. This one is too much, so it carries over. So we have a 5, a 2, and 9. 8 plus 1 is 9. So the answer is 925. Okay, now we have another method. The opposite change algorithm. This one could be confusing, but it actually helps us a lot because this is the method we kind of use when we estimate things really quick in our heads. So we had 189 plus 278. The objective here is look at these two numbers. Which one would be, can we round up to an even number? So if we had this one and we added 1, then we had 190. Since we added 1 there, we got to subtract 1 there because it's got to come out the same at the very end. So 278 minus 1 is 277. All right, but that's still going to be some moving around. So what else can we do? Well, in this one, if we add 10, then we get 200. So we take away 10 from this one. 277 minus 10 is 267. Now we can add them together. Let's take the same, we just had the last example, 568 plus 357. So this one is that. All right, so which one would be easier here? So let's look at this one. So if we add 2 here, we get 570. That means we have to subtract 2 there. 355. Okay, so we have 3 digits. We want to get a number that has 2 zeros behind it. So let's look at this one. If we add 30 to it, then we'd get 600. And if we subtract 30 from this one, you get 325. Now we can add these since we have 2 zeros. 0 plus 5 is 0. 5. 0 plus 2 is 2. 6 plus 3 is 9. So this is 925. And this is a method we'll use when we get to start estimating. 278 plus 277. Let's look at these two. So I add 2 to this one. I subtract 2 from that one. This one makes it 280. This one makes it 275. If I add 20 to this one and take away 20 from that one, I get 300. I get 255. 555. That's the opposite change algorithm. All right. Our number system is called a base 10. Because, oops, I can't focus that in. We're the base 10 system because we go from 0 to 9, which is 10 numbers. And we have 10 digits, which is what we call these numbers. We have digits. All right, so if we look at it, we have our number system going from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In other words, what this thing says is we cannot have a number bigger than 9 or less than 0. So 0, 0, 0, 0 plus 1, this is addition. 2, 3, 4, 5, 6, 7, 8, 9. 1 plus 0 is 1. 1 plus 1 is 2. 1 plus 2 is 3, 4, 5, 6, 7, 8, 9. Now, this is where it gets interesting because remember, we can't have a number bigger than 9. So we have 1 bigger than 9. There's no more than 1, so we're now in the tens column. 2 plus 0, 2 plus, so it's 4, 5, 6, 7, 8. 2 plus 8 is 9. 9 plus 1 is 10. And then we start with the next one. And it keeps on going that way because this is important. Each one of our numbers, well, we have the ones column. We have the tens column. We have the hundreds column. We have the thousands column, and so on and so forth. Since we're base 10, this first column is 10 to the 0. Anything 0 is 1. This is 10 to the first, 10 to the second, 10 to the third. We took this number of zeros tells you how many. So the number 347 means we have 3 100s. 4 tens, and 7 ones. Right, so that's a base 10 system. And this is how we would write it down. What if we had a base system, not base 10? What if we had a base 5 system? Or a base, well, we do have a base 2 system. That's called binary. So in base 5 system, we have numbers 0, 1, 2, 3, 4. These are the only numbers we can use. So we have 0, 1, 2, 3, 4. 0. So 0 plus 0, this is addition. 1 plus 0 is 1, 2, 3, 4. Now, once you get to this point, we have no more ones. We jump into the next column. This doesn't mean 10. That's 10's a base 10. This is 1, 0. So this is 2, 3, 4. 2 plus 4 is 6, but it says we have no more 5s. We have one more there. And this one would be 11. Or 1, 1, not 11. And so on and so forth. So this is 3, 4, 1, 0, 1, 1, 1, 2. 4, 1, 0, 1, 1, 1, 2, 1, 3. So these are the numbers. So if I gave you two numbers in base 5, this for me to write something in base 5, I'll have like a 2, 2, 3. It's not 23. It's 2, 3 base 5 plus 1, 4 base 5. So for us to do this addition here, what we would do is let's look at our chart. 3 plus 4. 3 plus 4 is a 1, 2. So it's a 2, carry the 1. And 2 plus 1 is 4. So our number is 4, 2 base 5. We have number 144 base 5 and 34 base 5. So we have 4 and 4. We do 4 and 4. That's 1, 3, which is carry the 3. I can't 3, carry the 1. So we have 1 and 4. 1 and 4 is 1, 0. 1, 0 plus 3 is 1, 3. So the answer is 2, 3, 3 base 5. All right, so that's the way we do addition in any other base system. We'll talk about base 2s next time. So again, and also for mental math and estimation, use that rounding up. So as if we had 67 plus 36, easiest way to do this is This is going to be 60 plus 7, 30 plus 6. So we know we have 90, which is 103. We do that now. So you can look at this, or even you just round it up for estimation purposes. We can say the closest number here is 70. 70 and 36 is 106. That's pretty close. And that's what we want in estimation. Use the rounding rules. Go to the closest number you can, the most even number, and take it from there. All right. So that does it for that section. And we're going to do subtraction, multiplication, and division later on, next time. Okay. Have a great day. Enjoy the sunlight. I'll see you guys Wednesday in class.